Okay, now let's start discussing interpretable models. As mentioned earlier, we have linear regression and decision trees in one of the examples, but there are more. But let's just focus on those because they're very straightforward. In linear regression, again, it's simply y equals mx plus b, but again, you have lots of features, lots of weights there, but it's the same conceptually. And the interpretation is very simple. For every 1 unit increase in a feature x sub I, the predicted outcome changes by beta sub I. So x sub I here is the input, and then beta sub I is the weight. So very straightforward, right? Again, but there are caveats in using linear regression. There are some assumptions like linearity, homoscedasticity, no multicoloration, and others. And logistic regression is also related to linear regression, right? It's just the classification version of linear regression. So you could also use logistic regression for use cases that need interpretability. And the other example is the decision trees. And this is a very, very straightforward model as well. It's simply if-else rules, right? So you start here at the root node, and then if, say, in the specific example, the value of sex male is like greater or equal to 5, then 0.5, I mean, then you will go to the left or the right part of the tree. You'll go to the left branch or the right branch. So I'll be reading this. So a decision tree splits the data based on certain feature thresholds, as I've mentioned earlier, forming subsets until reaching terminal nodes or the leaf nodes. Each leaf node predicts an outcome based on the average of the training data within that node. So at the end of it, after you traverse the different nodes, you'll end up in the leaf nodes, and then you can now make your prediction. So this is very straightforward, and you could explain this to even non-technical people. You just follow the rules that we're seeing here.